let us see what is chemical engineering.
In a simple word, chemical engineering is all about changing the raw materials into useful products such as clothes, food and drinks, and energy. Chemical engineering uses the principle of chemistry, physics, mathematics, biology, and economics to efficiently use, produce, design, transport, and transform the energy and materials. As a chemical engineer, you should understand how to alter the chemical or physical state of a substance. Chemical engineers focus on the process and products, so they develop and design process to create products. Chemical engineers often work in multidisciplinary teams with mechanical, electrical, and other types of engineers. Therefore, making decisions is the most important thing as a chemical engineer. They have to decide which reaction pathway should be used to make the product, how to purify the desired product, how to control the process and ensure it's safe, how to make the process cost-effective, what should be done with any byproduct form, how to reduce the amounts of unwanted byproducts, what to do with the unreacted raw materials, and how to recycle energy within the process. So, a professional chemical engineer should have analytical skills and problem-solving skills. There are many fields or courses related with chemical engineering, such as biochemical engineering, biotechnology, petroleum engineering, chemical technologies, electrochemistry, food engineering, and polymer engineering. So, chemical engineers are involved in many aspects of plant designs and operation, including safety and hazard assessments, process design and analysis, modeling, control engineering, chemical reaction engineering, nuclear engineering, and biological engineering.
Hello everyone, I'm Yi. Now I will explain about the jobs and companies for chemical engineering. Now, many people will think that a chemical engineer equals working in Petronas, Shell, or any gas company. But that's not true. Chemical engineers can also work in the food, semiconductor industry, and wastewater treatment companies such as Nestle, Micron Technology, and Water. Armed with knowledge in the field of science, chemical engineers are the leading figures in helping to design improvements to all technology and systems, which can even include designing an air conditioner that can cool your house faster. Chemical engineers also lead the way in developing a wide range of new products from a single source. For instance, a chemical engineer can develop jet fuels, lubricating oils, gases, cosmetics, and fertilizer, all from a single source of petroleum. Now, that's pretty cool. To become a chemical engineer, having exposure to subjects such as physics and mathematics in secondary schools will help a lot, as these science subjects will form the backbone of what you will learn in university. Many people like to think that chemical engineering holds chemistry only in focus, but that's not true. Chemistry is but a small part in many other important subjects in university that you will learn to be familiar with, such as thermodynamics, transport and separation processes, and material balances.
Next, I'll be explaining about the concept and basic working principles of distillation column. Actually, distillation column works based on the integration of material balance and energy balance. There are several types of distillations, including simple distillation, fractional, steam, immiscible solvent, azeotropic, vacuum, molecular, and trainer sublimations, and so on. So this is our distillation column. Distillation column is an equipment used to accomplish distillations of liquid mixture based on the differences in the component volatilities. In simple words, distillation column separates the component mixture based on their difference in boiling point. There are many components in distillation column such as condenser, reflux and reboiler. Distillation column has one feed inlet and two outlets at the top streams and the bottom stream. The feed phase can be liquid, vapor, or the mixture of liquid and vapor. The top stream is known as the rectifying sections, while the bottom stream is known as the stripping section. Condenser is used to cool down the vapor, leaving the top column, while the reflux is used to recycle back the condensed vapor to increase the purity of the distillate. Lastly, the reboiler is used to vaporize the liquid and return it back to the distillation column to drive the separation process.
All right, thank you, Ying. So just to sum up, a distillation column is actually quite useful if you like to purify a substance by separating it from its impurities. All right, a simple one might be the process that you guys have actually learned before, which is petroleum cracking or fractional distillation of petroleum, where you can actually get many useful compounds that can be separated in a single distillation column system. Now, here in university, which is something that you guys might not have heard of it before, is we actually look at a lot of parameters such as the efficiency of the system, which tells us how good that system is in performing its function with respect to the amount of resources invested in it, right? So the higher the efficiency, the better the value you're getting out of a single system. Besides, we also learn about many other different concepts, such as how fast the amount of substance going into and coming out of the distillation column, that is commonly known as the distillation column's inlet and outlet flow rates. All right, and understanding the flow rates allows engineers to figure out exactly what the structural limitations of the distillation column is, as well as deciding, wow, how much can it actually cost, or how can I reduce the cost of the distillation column such that I can have a cheap distillation column, but have that distillation column perform at a very optimal level. Besides, there are other things to take note of, such as the composition of the flow rates, the number of trays of the distillation column, the height of the distillation column, and many other considerations to take note of. So as you can see, in essence, we are learning the same things as you guys learn in secondary school, but we're actually going much deeper into the distillation column. We actually look at individual parts, not the overall system, and that's what makes studying chemical engineering is all about in university compared to chemistry in secondary school.
So what does this all mean? Well, this shows that a chemical engineer is one of the most important jobs in the world today. Now, the requirements for being a chemical engineer might not be as high as you might think. So why not give it a try, and we hope to see you becoming a successful chemical engineer in the future. Thank you guys for watching, and that is it from our team. Thank you.